Welcome to our lecture about Internet weaknesses and targets. This lecture is an overview about Internet and web technologies. This is the content table of our lecture. We start with an introduction. We already start with an overview about Internet security. The second overview lecture is now the lecture which recalls us to the Internet technology, to the web technology. This is very important to understand this because later on we discuss weaknesses of the Internet protocols, weaknesses of the web technology. And for that reason, it's important to remind you about this Internet and web technology. The next chapter then is risk analysis and cybercrime. And then main chapter of the lecture, main lectures are on Internet weaknesses and targets, detection of attacks and intrusions. And finally, in our lecture, we want to think and discuss some ethical and legal issues in Internet security. So today we start to speak and to give an overview about Internet and web technology. You all know, meanwhile, almost 1 billion of hosts are connected, all over the world, are connected to the Internet. The number 900 million hosts is a recent number from July 2012. It's a little bit difficult to estimate, but around 1 billion computers, devices, hosts all over the world are interconnected by this Internet. So the Internet is a great success story. And of course, if people use the Internet, if people connect their computer to the Internet, security becomes a key factor for using Internet and web. To secure their own computer, to secure communication, to secure the content that is communicated via the Internet, to secure the applications that can be accessed over the Internet. So it is a very big topic, and when in this lecture we want to discuss some of the weaknesses to learn in which point we have to be very careful when using Internet and Internet-connected IT systems. So the detailed knowledge about networking, about the Internet protocols, about the web technologies is necessary to understand the various security problems. The various security problems occurring around the use of Internet, occurring around the use of web. To understand the technology helps to see where are attack points, what have to be secured to be sure that the systems are used in the way the user wants to use them. A detailed knowledge about networking, Internet, and web technology is necessary to understand the different threat scenarios, to understand the different attack methods, as well as the development of the appropriate protection measures. Protection measures that secure systems that are connected to the Internet. What is the Internet? You all know Internet is not a general network. Internet is a virtual network. It is a network of networks. And the illusion that this network of networks provides one net. This is provided by the Internet technology. Let's start to have a look on the computers, on the hosts that are, on the devices that are connected to an Internet. Here we can distinguish computers in two different roles. One role of a computer connected to the Internet is the role of a server. A server provides resources for other computers. So a server is waiting, passively waiting. He can be accessed over the Internet, and he provides a service, a resource, a document, an application that he offers for the use of other computers. And the other role of computers in the internet are the role of the client. These client computers, that are the computers that make use of the services provided by the server. Clients make use of the resources that are offered by the server to make use of them for own computation. So in this interaction model, we have a server that's passively waiting, that's able to provide a resource, and then we have the active partner, the client, who wants to make a computation, needs resources, knows that he can get a resource from a server, and then he takes and requests the resource from the computer. So the components of such a computer network, beside of the computers, of course, are the transmission media. Transmission media could be a cable, could be other physical media, for example, the air. And these media are used to interconnect the computers in a sense that this media provides a channel. The computer can exchange signals. And a couple of signals, a pattern of signals, that is carrying the content, the data. So transition media that are connecting the computer may be wired, for example, twisted pair in an Ethernet, or coaxial cable, optical fiber, or others. Or this transmission media may be wireless, radio waves, infrared signals, or Bluetooth. And the third component that is needed to form and to run such a computer network, that are infrastructure components. These are the three components of a computer network. With this infrastructure components, we understand, for example, network adapter. Network adapter that transform computer data into electrical or optical signals that could be transferred through to the transmission media. That transforms the computer data into radio wave signals or others. This is one part of the infrastructure network, and the other are various different types of intermediate systems. Intermediate systems for signal refreshment and others. So these are the components of one computer network. We are not yet speaking about internet. We are speaking about computer network. And there are technologies that allow computer to transfer information, to communicate via such a computer network. Example for such technology, for example, is Ethernet or FDDI or ATM. Now, we are interested in the internet. And I mentioned already that within the single computer networks, but also among the different computer networks inside the internet, so-called network protocols are used that provide the possibilities to transmit information over such computer network or over the internet. Here is a large map to show you only, it's not necessary to see the details, but it should show you that there is a lot of different protocols that are needed to implement such communication task. To say it roughly, such network protocols, they need to define the format. The exact format of the transmitted data, piece by piece, so that both systems, the sender and the receiver, are able to interpret these messages in an exact way. Then we need an address scheme. Each message that one computer wants to send to another computer needs to be addressed with the address of the receiver. Then these network protocols, they have to exactly define each step in the communication process, from the starting, eventually establishing a connection, then sending the message, then eventually delete the connection. So each step very precisely needs to be ruled by such network protocols. But network protocols have to do more. They also need to provide means to control the communication process, to see whether communication works well, to find out whether there is an error, to find out the reason for the error, and others. So these network protocols are the software that is needed to implement computer communication. If we have a look to such computer networks, then we see very different types of such networks. One can try to classify these different computer networks, and there are different parameters and different aspects that can be used to classify such a network. For example, we can use as an aspect in geographical scope. We can different types of connection. We can consider different types of connection, different types of usage. Let's start with a classification based on the geographical scope. This is mainly a classification on the scale. So we see such computer, we can find and exist some very tiny computer networks. So for example, in the size of 0.1 meter, in the centimeter, right? When we look to ships and PCBs, these ships and PCB provide multiprocessor systems, and of course, is our network of computer. There are other networks of computers. They are in a system, in the scale of a system. So multiprocessor clusters, 1 meter around. These are such multiprocessor systems. We can see and find a lot of networks situated in a room. These are so-called personal area networks to connect the host computer and PC with a printer and some other device. There are networks that connect computer within a range of kilometers inside a building, on a campus like in HPI. These are the local area networks, the most common form of computer networks. Then we see networks that connect computers within a city, so in several kilometer distance. These are the so-called metropolitan area networks. Or when we enlarge our scale to 100 to 1,000 kilometers and consider computers that are connected inside a country or inside the continent, then we have these wide area networks. And finally, if we look networks that connects computer around the planet, then of course this is the internet. There is another important point to think about when we speak about computer networks. On the one side, we know and speak and see so-called distributed systems. And on the other side, we have computer networks. Of course, computer networks in a certain sense are distributed systems, and distributed systems are computer networks. But what people understand if they speak about distributed systems and what people mean when they speak about networks. Between these two notions, there are common properties. Common property as well from distributed system, as well from computer networks, is the cooperation of many individual components. Components that are physically and logically different. Computer networks, these are the computers. In distributed systems, these are the different components. And another common property of this both of distributed systems and computer networks is that the individual components are spatially distributed and operate autonomously. They operate autonomously, but in cooperation with the other autonomously operating components. Beside of the common properties, there are differences. Let's start with considering distributed systems. In distributed system, each involved component works transparently. Works transparently and is usually managed by a control process. That means transparently, one does not see which component is responsible for what process. This is organized inside of the distributed system. Organized, it's controlled by a control process, and it's not important to know for the user. So what happens on a component is unavailable for processes as other components, as well as for the end user. If we consider computer networks, then this is different. A computer system, a computer network is controlled by a network operating system. And this network operating system that controls the processing steps of the user request. And in a computer networks, the user can realize which part of the network has done what computation. I come back to the classification of computer networks. We already classified according to a geographical criteria, but we can also classify such computer networks along other criteria, for example, along the usage. For which purposes this network was created, for which purposes this computer network is used. So here the first group are function-sharing networks. Function-sharing networks make different functions available at different locations. And so they allow the access to specialized services. For example, to supercomputers or to vector computers or tablets or other things. Besides of these function-sharing networks, we can see such load-sharing networks. Networks that provide a uniform usage of resources by distributing the workload on different computers. So same work is done, but the network is used to guarantee that the service is provided even if there is a large access to the service. Another type of networks are data sharing networks. Data sharing networks for better utilization of disks, of increased availability, increased safety, or in others. We can classify networks as high reliability networks. These are systems that guarantee functionality with a very high probability by providing redundant systems. So another system will take its functionality if the system fails. We have more classification criteria. We can classify according the type of the computers that are connected, the type of the devices that are connected to the computer network. are all computers of same time, then it's a homogeneous network. Are computers of different type, then we have an inhomogeneous different. We can classify according who has what kind of access to the system. We can distinguish between open computer networks and private computer networks. The open computer networks, they provide open access. Access, for example, by paying some money or getting these resources. The other thing is the private computer networks, an enterprise network. Access to such type of networks is only limited to a special group of users. A very important type of computer networks are such virtual private networks. Virtual private networks, VPN, they provide on the basis of the internet. Internet is an open network. They provide the feeling and guarantee the user that he can use these resources of an open net in a very private manner. So by means of cryptographic technology, this open network is closed and usable only for the people that know this cryptographic identities. If you want to read more, here are a literature tip. In this overview lecture, we can give only a very short overview about this topic. Let's say a few words about Internet and Internet protocols. I mentioned Internet is a network of nets. So it's not a physical network. There is no uniform technology to use this network. It is a network of computer networks that use very different, sometimes incompatible technology. So Internet is a virtual computer network. Physically, it consists of different computer networks. But these different computer networks are coupled by means of intermediate systems like gateways and routers. And the illusion that this network of networks forms a homogeneous network, this illusion is provided by software, by the internet protocols. So this is a big difference to a computer network. Computer networks, there is a software, a firmware, and some special technology that helps that the data can be exchanged between these computers. But these different networks are interconnected by means intermediate systems, gateway routers, and others. And then over all this network of networks, these internet protocols help to provide the users a feeling this is only one network, it's a homogeneous network. So these internet protocols have to specify a lot of different things. They have to specify how the different participants can be identified. In each computer networks, each computer has an address. But two computers in different computer networks can have same address. But if we interconnect these networks to form an internet, then of course these two computers with the same hardware address, they need different internet address. So we need, the internet protocols need to specify how participants of the internet are identified. These internet protocols have to find out and have to specify how to target of the message, how to transmit a message, over the different interconnected networks from the sender to the receiver. The internet protocols have to specify which path through this connection of networks should be taken by the message. It should be a short path. The internet protocols have to specify how the message completely arrive at the receiver side, how a receiver can receive the message without errors. So many more other tasks need to be done by the internet protocols. You see, this is a very important piece of software. Let's have a short look, only a graphical look, to the structure of the internet. What we have are the regional networks. And the regional networks are interconnection of so-called stub networks, of networks in a company, of networks at home, of companies in a university. And all these networks that are in a region, they are interconnected by an internet provider. And then we have another region connecting other networks, computer networks to each other. And then there is a backbone network that helps that these regional networks, even if they are in different parts of the world, that they can exchange messages. If we have a little bit closer look, then we see, for example, here, this is a typical situation that we have a cable net. Cable net inside a company. There are switches, there are hosts, and they are connected, for example, by an Ethernet. We can here is another Ethernet, a local area net, or an ATM net. We can help that computers can communicate with such a local area network via wireless by means of such wireless local area networks. You see there are different technologies. Also, we can use GSM to connect mobile phones by each other, to connect mobile phones to the internet, to provide users of mobile phone, of smartphones, access to the internet. In large areas, we can, instead of using GSM, we can use satellite networks. Telephone networks, a very traditional model. And all these different types of networks can be interconnected. What we need are such intermediate systems that as well understand technology that's used here and technology that's used here. We have to, such intermediate systems are needed in all places. And then we can interconnect all these different computer networks by means of the internet. Internet technology, this way, this ability to interconnect computer networks around the world has changed our life, has changed the way we communicate, has changed the way we work, the way we make a business, the way we make shopping has very much changed. So here I only have looked to one market area, the electronic market for learning. So with our Open HPI, we provide worldwide massive open online courses. So several thousand people can get access to our learning material of the Hasso-Plattner-Institut in Potsdam. They can access it, and via the internet, we can not only provide lecture recordings like the tele-TASK recording, like this recording, we can also provide possibilities for interactive self-tests, quizzes, homework. We can offer discussion forums and other things. And it is possible by means of the internet. Let's have a closer look to the internet technology. If we consider such computer networks, then typically the network technology is a closed technology, a proprietary technology. There are companies, you can buy this technology from the company, and then they guarantee you that in your local network or in this other type of network, you can communicate. These secrets of this technology, the patents describing it, they are owned by industry. If we consider the internet, then we have a complete different situation. Internet is an open system. All specification, all protocols, all standards are publicly available. And any company, any student, any interested person can get access to this information and can build their own application, their own services, their own business drivers based on the standards. Also, all the internet documentations are free and are online available. And this freeness, this open source, this open system culture definitely can be considered as one of the drivers and one of the explanations why this internet technology was increasing so fast in so short time. So this exponential development of the global internet that has, the internet is not so old. The internet is the internet as we know it. It becomes available to everyone by the web technology is about 2 decades old. The origins of the internet, later on I will go back in history, is to 69. So in a very short time, the internet received an exponential development, and this proves that this open system culture has a strong power and has very much fastened the technological development of the last decades. Now the question is how this internet protocols, how this communication protocols are organized. It's a very complex task. If you think one has a message you want to send, this message has to be understood by the computer, has to be transferred into physical signals, has to send over a wire, has to be refreshed. On the other side, this process has to be back. So it's a very complex task. And so conceptually, these internet protocols and other communication protocols are designed in so-called hierarchical layers. And the idea of this hierarchical layer is to divide and modularize the problems so that in a certain layer, a certain amount of tasks are regulated. And protocols in one layer, they give their results to the protocols in the layer beyond them, and they take the information from the layers below. And in this way, the large task, the large challenge to organize, to realize, to implement communication is broken into certain pieces which are hierarchical organized. There are 2 famous layering models for communication. The theoretical one, is a OSI reference model, and that what's important for us is a TCP model, TCP/IP model, and the TCP/IP model, that's the model of the internet protocols. TCP and IP are very important, perhaps are the most important protocols in this suite of internet protocols. So the internet protocol stack got the name from these very important protocols. So here you see the OSI, the OSI reference model, and on the other side you see the TCP/IP model. The OSI model has 7 layers, the TCP/IP model has 4 layers, and but of course they try to do the same, they try to organize communication, so there are similarities. In the following, I want to go into the details of the TCP/IP protocol stack and have a closer look to this model. From the bottom, there is a network interface layer. This network interface layer is responsible for the data transport packages over specific networks. Then on top of the network interface layer, there is the internet layer. The internet layer that handles the communication from machine to another machine by encapsulating these IP packages into IP datagrams, giving them IP addresses, and routing these these packages through the interconnection of networks. The most important protocol on this internet layer is the IP protocol. On top of the IP protocol, we have the TCP protocol. The TCP protocol provides a universal transport service for communication applications, for an end-to-end application. And the most important protocol on this layer is the TCP protocol, but we have also to mention the UDP protocol, which is much simpler and usable for organization and administration data. And then on top of the transport layer, the application layer, which provides functionality that service and applications on the different computers can communicate with each other by means of the internet protocol. So here we have a lot of different protocols, HTTP, SMT, FTP, and each of this protocol corresponds and makes one application possible. HTTP, it makes a protocol, hypertext transfer protocol for the web, for the World Wide Web. SMTP is a protocol that enables, that helps to have the email communication, FTP for file transfer, and many application protocols there. Let's have a closer look to the network layer first, sometimes also called link layer. This this term network layer, this suggests the closeness of this layer to the physical layer. Physical layer sits the layer, for example, the Ethernet, the WLAN, the WLAN, or others that are interconnected, and of course the IP protocol has to interact with these different physical networks. The core protocols specified by the Internet Engineering Task Force, which are placed on this layer, are the Address Resolution Protocol, the ARP protocol, the Reverse Address Resolution Protocol, the RR protocol, the Neighbor Discovery Protocol, NDP, for delivering similar protocol functionality like ARP for IPv6. Then layer 2 tunneling protocol, which is a tunneling protocol for VPN. The media access control protocol, the media access control are in this layer. So Ethernet, DSL, ESDN, FTDI, you see, close to the physical networks that are interconnected by the internet. Next layer, on top of this network access layer, is the internet layer. Here, this internet layer consists of a group of methods that makes it possible that messages from different physical networks can be exchanged. So internet working protocols, internet working methods, specifications that are used to transmit datagrams from the host to the destination host. The core protocols of the internet layer are, of course, the internet protocol, IP. The internet protocol, there exist two versions, two actual versions. There's a version IPv4, that is a protocol that's commonly used today. And then there is a new protocol, a new internet protocol, the internet protocol IPv6. And what we will see in the next years is a migration from IPv4 to IPv6. The reason is there are no more free IPv4 addresses. Then we have the Internet Control Message Protocol, the ICMP, in a version for the IPv4 protocol as well as for the ICMP-v6 for the IPv6 protocol for error handling and diagnostic functions. We have the Internet Group Management Protocol, IGMP, for groups, for grouping IPv4 hosts and adjacent multicast routers to establish multicast group. We have the Internet Protocol Security Protocol Suite, IPv6, for securing IP communications using authentication and encapsulation. In the internet layer, a few more words about IPv4 and IPv6. The main difference between these two protocols is the shape of the addresses. I mentioned already the interconnected networks. In each of these interconnected networks, each computer has an address. But if we interconnect different networks, then a new address scheme is needed. So the Internet Protocol is responsible to provide such an address scheme. And in this address scheme, the shape, of course, needs to be fixed. So in IPv4 addresses, we have this 32 bits long addresses. And it was good and enough for the first years of Internet. But now we are in a situation that this length of the IPv4 addresses is too short. And you know, if there are 32-bit long addresses, then maximally 2 to 32 different IP addresses, IPv4 addresses we can have. So it's about 4 billion. And this 4 billion is not enough for the requests today. Because meanwhile, we not only want to connect one person's computer to the internet, we want to connect his laptop, his smartphones, we want to connect radios, household devices, TV, we want to interconnect cars, we want that cars can communicate via the internet. So IPv4 is not enough to do this. So what was needed is an address scheme, an internet protocol, which provides much more internet addresses. And this is the new protocol, IPv6. The new protocol is not so new. It's already 10 years. It was already designed 10 years ago, because in that time, people understood that the 4 billion will not be enough for future needs. But the problem becomes aware in last year when the last free IPv4 address was assigned to an internet provider. So in the moment, there are no more free IPv4 addresses. So let's have a short look in comparing these two protocols. So specification of IPv4 was done in 1981. The specification in RFC 2460 for IPv6 was done in December 98. The address size in the old-fashioned IP protocol is 32-bit, 2 to the 30-bit different addresses, 4 billion. And the new length, the new bit number for IPv6 is 128. So if we compare the numbers, there are a vast difference in between. Here, about IPv4, about 4 billion. Here, this number you can not really realistic express. It's 340 trillion of trillion addresses. So each CENTCOM in the world can get an own IP address. There are different formats to describe these addresses. Here with dots, 4 groups, 4 digital groups, 4 groups of digitals, each group with 3. Here we have an hexadecimal notation, I have no chance to go into more details, and also different types of notations. On the top of the internet layer, there is a transport layer. The transport layer offers the services such that a connection-oriented data stream can be supported, such that guarantee can be given that the data which are sent by the sender receive the receiver without error in good quality. This transport layer is also responsible to organize flow control, congestion avoidance, and multiplexing. The protocols on this layer, the most important protocol is a transport transmission control protocol, a very complicated and also often modified protocol, which allows a connection-oriented transmission. There is a much more simpler UDP protocol for a connection-less transmission, also without any guarantees. And then there are more protocols like datagram congestion control protocols, the stream control transmission protocol, or the resource reservation protocol that are needed to fulfill this task, to guarantee, to organize the flow control, to avoid congestions, multiplexing, and others. And then on top, there is a final application layer. The application layer is a home of the protocols that support the network access of services and applications on the host computers. Such services and applications that want to use the internet to communicate with an application or a service on another computer. So here, these protocols provide what is called a semantic conversion between associated application processes. The application layer focuses more on network services, on APIs, on utilities, and operating systems environment, and popular protocols from the application layer is a large variety. I want to mention HTTP, IMAP, DNS, SMTP, I couldn't mention all, IMAP, IMAP4, SNMP, Telnet, SNN, POP. So for accessing the internet, for being able to send emails, for receiving websites, and others more. If we speak about the internet services and applications, then the services are provided in the application layer. The service himself does not belong to the TCP/IP stack, but in the application layer, there is a protocol that makes it possible that an application can make use of the internet and can get access to the protocol stack. Typically, in this application in the internet, we see the client-server principle applied. What does it mean? I mentioned already the client, that's a process actively requesting an information or a service from the server, and the server passively is waiting, willing to provide such services, and if a request is received, then the server responds with the expected information, with the expected resource or service, or if it's not able to do this, or the user, the client is not authorized to use it, then an error message is sent. So client and server in the internet application, they interact by exchanging messages over the network. So client-server is a kind of simplified communication model. The internet provides a lot of important services. You know them all. There is a file transfer. This file transfer is the protocol in the application layer that makes such file transfer possible is the FTP protocol. We have the naming service that in an internet, not only the IP addresses, this couple of numbers can be used, but in internet, also names can be used. And to interconnect this number, this IP addresses with the domain names, this is organized by the naming serving and the protocol that makes this possible. It's a DNS, a domain name service protocol. We have directory services. We have message exchange systems, for example, email, which is based on SMTP, MIME, or PGP. We have internet chat and a protocol, IRC for this internet chat. We have the famous World Wide Web with the HTTP protocol. It is based on and more, you know them all. Speaking in more detail about this World Wide Web. The World Wide Web is one application of the internet, but it is the application, the most important. So let's have a closer look to this application, to the applications, the World Wide Web, that made the internet such an important tool and the basic communication infrastructure of our modern society. World Wide Web, shortly WWW, W3 or web, is the most important internet service. It is an interactive, distributed hypermedia system. Here are different words. Interactive means you can interact. The resources are distributed all over the world, and the resources are hypermedia. Originally, it was text. The media were text, so it was hypertext. So the name of the protocol is Hypertext Protocol. But meanwhile, the media are images, are movies, are music, or other things. It are multimedia documents, and the idea of the web is to give everyone a very simple access to such multimedia documents. Originally, it was designed in the Nuclear Research Center, CERN, but soon there was the client for the World Wide Web, the so-called browser, came with a graphical user interface, with a GUI. And this graphical user face, that makes it so easy to request some resources. You have to move on a page and you see there are some underlined, some words, and the underlined means there is a link connected to this word. You make a mouse click, and then the mouse, by means of the mouse click, the request of this information connected to this word or to these images is requested. So this graphical user interface brought the World Wide Web out of the world of specialists into our general real world. Browser, this is a piece of software you need to request and to consider and to view such resources. This is a client, and was interesting history coming from different providers. So today the most famous browsers are Chrome, Internet Explorer, Firefox, or others, and they are cost-freely. They make cost-freely used by everyone. For the history of the World Wide Web, it was introduced in 1989-90. It was introduced by Robert Callieu and Tom Berners-Lee. And they designed this service as a service for an internet-based exchange of administration of experimental data. Experimental data that were reached in the European Organization of Nuclear Research, shortly CERN. And the idea of this common European research organization was that researchers from all over the world, mainly from Europe, attend and work in this research center for a couple of weeks or months and then go back to their home institutions. New researchers come. And the question was how to interchange, how to find an easy way for interchanging this experimental data. You know, this nuclear research provides a large amount of data. So the World Wide Web service was originally designed to help researchers to exchange research data. The World Wide Web is based on the following three basic standards, and these are the columns the World Wide Web is based on. There is a language, the HTML language, the hypertext markup language, which specifies the format for describing such hypertext, hypermedia documents, so-called HTML documents, and the HTML documents that are the resources of the World Wide Web the World Wide Web is based on. Second column, second basic standard is URL standard, Uniform Resource Locator. And by means of the URL, the resources in the World Wide Web may be addressed. So URL provides an addressing scheme that indicates the location of the data in the internet as well as the use protocol to access this data. And then the third basic standard and column of the World Wide Web is the HTTPI protocol. We already mentioned it when we discussed the protocols of the internet application layer. The hypertext transfer protocol. And this is a communication protocol for requesting and receiving the HTML documents. What makes www so interesting is that it consists of hundreds of millions of hypermedia documents distributed around the world. All these documents are described in the hypertext markup language, HTML. So these hypermedia documents may consist of different components. They may consist, of course, of the text, but the name hypertext or hypermedia shows that beside of the text there are also links, so-called hyperlinks, part and included in that document. And the idea of this link is that they provide a possibility to connect one document with another document. Interestingly, the other document need not to reside on the same computer. It may reside on a computer, on another service, on another place. Originally, it started with hypertext. Meanwhile, we have hypermedia, audio, graphic, video, and other media that may be interconnected by hyperlinks. So these hypermedia documents can very easily be accessed via a mouse click from one browser, even if this document resides on a computer on another part of the world. So these hyperlinks, these are the main characteristics of an hypermedia document, providing the possibility that the original sequential order, for example, inside a text, can be broken into a network, into a complicated shaped networks of interconnecting information. Everyone, every user can go his own way through different documents, depending on his special interests, on his favors, on his wishes. So one can go this way, another can go that way to come here, another can go this way here to see that, and then go here and not in this direction. So these hyperlinks are main characteristic of the World Wide Web. To access such hypermedia documents, each of these documents need a name, a unique name. Because otherwise, the computers do not understand which document the user wants to get. So a naming scheme is needed that provides a possibility that each document on the world may get a unique name. And this naming scheme, the naming scheme, which fulfills this characteristic, is the URL. The URL, the Uniform Resource Locator, identifies a resource by the internet name of the computer. Also in the internet, each computer needs an address. You remember this was a task of the internet protocols. Now each document needs a name, and one part of the name is the name of the computer where the resource is located. And the other part of the name describes the path on that computer to reach this resource. The transmission of the hypermedia documents in the World Wide Web was done by the HTTP protocol. This HTTP protocol is a very, very simple protocol and is designed to access such HTML documents over the internet, providing the possibility to request the document and then to receive it. The HTTP communication follows this very simple request-response scheme. Each data exchange between the sender and the receiver is completely independent from the previous interaction and data exchange. One is saying that this HTTP protocol is stateless. There is no remembering on interactions that was done before. Reason was to design the HTTP protocol in that way was that it should be very simple. In the time when it was designed, bandwidth was a very variable and very it was only available in a limited amount. Then HTTP protocol should be usable by very different devices, also by smart mobile devices. And it should work even with old computers with not so much performance. What is the situation today? We see much more new application. So the World Wide Web is not only for providing documents, Word documents. Sometimes this is called Web 2.0. That's the new behavior of the World Wide Web. And if you see here around the things that's provided in the new World Web, they are commonly associated with new web applications where people themselves can publish content. So with a lot of interactive information sharing possibilities, interoperability, the user-centric design, collaboration on the web. So we see applications like blogs, like folksonomy, wikis, long-tail affiliation, CSS data, RSS, mobility, video, audio, to mention only a few words. And also the already mentioned OpenHPI learning platform is a Web 2.0 application. So this Web 2.0 does not refer to a very special technical specification. It refers more to how the web is used today. Examples I mentioned already: social network sites, blogs, wikis, video sharing sites, hosted service, web service. This is what Web 2.0 is characterizing. And there are different technologies involved. For example, XML, RSS, SOAP, asynchronous JavaScript, and XML, this is Ajax, Adobe Flash, and many others more. Let's have a look, when we speak about the World Wide Web, about the two partners, the client-server paradigm, and the basic architecture of the World Wide Web. Here, the client is the browser. And the client requested from his or her browser a document from a web server. So the web document is characterized by the URL, is identified by the URL, and for communication between the browser and the server, the HTTP protocol is used. This was already discussed before. So the server accesses the specified document from its local file system when the browser has requested it, and then sends it back to the requesting browser. The browser is not only responsible to request such a document, browser is also responsible to present the received document to the user. And this is this makes the browser a quite complicated piece of software with an interesting architecture. The architecture of the browser is much more complex than the architecture of the web server. Beside of the communicating with the web servers, the need to be able to interpret the received document, the need to be able to display the received document correctly, this makes it necessary that the browser has some more complicated things inside. The way browser is working is that if user requests a document by a mouse click, then the browser opens a connection to the specified word server and choose a server which is characterized by the click the user has done. Then the document is requested, the document is received from the server, and then the document needs to be interpreted, need to be rendered, and need to be displayed on the interface. And in addition, the browser needs to be able to react on actions of the user. For example, more mouse clicks, other mouse clicks, some mouse clicks, for example, in an image map, and other things. All this, the browser has to understand and has to react in the right way. For that reason, the browser consists of a couple of different components. Browser needs a controller that supervises all browser functions and interprets the mouse clicks of the user. A browser needs an HTML interpreter. This interpreter is needed to interpret the HTML document from which the vast majority of resources on the web comes from. Then, typically in recent browsers, there are various other clients involved. Other clients for accessing other internet services, for example, email service or others, because meanwhile the browser is widely accepted as a standard service client. And then browsers need to be able to efficiently react. They need caches for parking visited pages to increase efficiency, to decrease the waiting time for the user, to decrease the amount of data that is interchanged between the different computers on the internet. Let's close this lecture with a short view on the history of the internet and the World Wide Web. In the 60s, the idea of packet switching came up. You remember in the telephone communication, the two partners establish a line, a connection between, and then they can use this connection line for interacting, and nobody can disturb them. This is a model that does not work well for computer networks. Computer networks can be run much more efficient if the data are sent in form of independent packages that are sent over the internet, that are switched over, not the internet, that are switched over network. An idea about this came in the 60s. The internet project started 67 when the so-called ARPANET project was started. And the internet came to life in 1969 when the ARPANET, the first ARPANET, starts to work. It works with 4 nodes in universities on the West Coast, 3 of them on the West Coast of US, 1 in Boulder. Then, shortly afterward, same was established on the basis of a radio network. This was the Aloha net connecting the Hawaii Islands within a radio transmission network. Then, 71, first email was sent. 71, you see, it's 50 years. It's 40 years. 40, not even 50 years. So it is a new, something new. You are thinking, you are young people, you are thinking that internet, email and internet exists forever. When I was young, email was not available. Then you see in the beginning, it needs a time that the ARPANET becomes bigger and bigger. 4 years later, 4 years after the start, it had already 35 nodes. And in that time, 37, Winston Cerf and Robert Kahn developed the TCP protocol, which is nowadays one of the bases of the internet. By the way, both Winston Cerf as well as Robert Kahn are fellows of the HPI. They visited us in conferences, and both became famous because they were involved in the development of the T protocol. In this sense, they are something like the inventor of the internet. 83, there was changed the ARPANET to use the TCP/IP protocol, our internet protocol. So you can say 83 is a birthday. If this is, ARPANET is a grandmother, then this 83 is the ARPANET with the TCP/IP protocol. That is the birth day, the birth year of our internet today. So it is 30 years ago, 30 years old. 86, it's the start of the NSF, the National Science Foundation net, which aims to connect all the universities in the US by a high-speed network. Then 88, the first internet worm, so the first security attack was done in the internet, and it was quite successful in that time because this first internet worm disturbs 10% of the whole internet hosts. At that time, the internet hosted about 60,000 hosts, and 6,000 were affected by the worm. 89, the internet connects the 150,000 hosts. So this 89 was also important because this was also the year 89-90 when the World Wide Web was born. Robert Callieu and Tom Berners-Lee developed the first web server and the first web browser. Then the first browser, as we know, as we understand browser today, was published, was 1993. It was an NCSA Mosaic browser. And the important thing of this browser was a graphical user interface. So from that time on, the World Wide Web was exploding because with this graphical user interface, everyone was able to use the internet, even if he or she did not understand anything of the internet technology. 94, Netscape and World Wide Web consortium was founded. Netscape was a company coming out of a university of this NSCA group that started to create an own company. Then there was a browser war. The World Wide Web Consortium was founded to regulate standardization in the development of the World Wide Web. 95, then Microsoft with Windows 59, 95 came with power into the internet with the Internet Explorer, and then we saw this development. I cannot go into the details. The development I mentioned with the Web 2.0, or I like to say better Web 3.0, to mention all the main development lines of the World Wide Web. This is semantic web, this is service web, and this is social web application. And resources, Google comes famous, YouTube, Twitter, Facebook, LinkedIn, and others. And in a very short time, worldwide acting companies were come out in this world of the internet. What was here? The February, this was an important date. Sorry for switching it over. Last year, the last free IPv4 address was assigned to an to a continental registry, and so nowadays all the IPv4 addresses have been inside out, and we need to change to go to IPv6. Who is who in the internet? First, I mentioned it's an open system culture, and there is no central point for administration, for supervision of the internet. There is no government, there is no police, so it is a very interesting phenomenon. However, to order to let the internet and the World Wide Web run in a satisfying way, international organizations were founded that working for the standardization of the different involving technologies. So one has to mention the Internet Architectural Board, the IAB, which directs the further development of the internet. One has to mention that this IAB has groups. This has an RFC editor. RFC are requests for comments. This is the standards in the internet, and it consists of about 10 so-called internet task forces that are responsible to discuss, to do a certain problem. The two most important internet task forces are the Internet Research Task Force, the IRTF, and the Internet Engineering Task Force, the IETF, which coordinate the research and the development work of various research group companies around the world. Although we try to contribute, you are invited to contribute. It's a very open structure, and this openness was one of the main factors to make internet in such a short time so important. Then we have the Internet Assigned Number Authority, the IANA, originally was responsible for organization and allocation of the internet addresses. Nowadays, this is done by the ICANN, the Internet Corporation for Assigned Numbers, names and numbers. That comes that internet was originally a project inside US. Meanwhile, it's a global project, and so some reorganization were done. All these organizations are carried by an international non-profit organization, the ISOC, the Internet Society, which was founded to supervise and coordinate the international development of the internet. So meanwhile, ISOC has more than 6,000 members from 170 countries and more than 150 national and regional chapters. The Internet Architecture Board has become a part of ISOC, so this ISOC is a unifying structure, a unifying organization that is responsible for all the developments in the web and the internet. Let's close this lecture by a few words about the process of standardization in the internet. The success of the internet, I mentioned this already, and as well as the success of the World Wide Web, is based on the use of standards. And the question is how these standards are defined. Different than in other ways, the standardization in the internet is a cooperative process of all the above-mentioned organizations. TCP/IP technology is open. TCP/IP technology is not proprietary. Everyone can learn and implement it. So all standards, and interestingly, standards are called requests for comments, RFCs, are published online and are freely available. Nothing can become a standard, also this is a very important principle in the internet, without a practical implementation. Without two practical implementation, without two different, independent practical implementation. So the standardization is done by this, I mentioned this already, request of comments. These standards are published by the Internet Engineering Steering Group, the EISG. And the EISG consists of the chairs of the EITF and area directors and or the Internet Architecture Board. The starting point for such a standardization process is a so-called internal draft. The EISG looks on this internal draft and then says yes, it can be published. Then it's published as an RFC proposed standard. Then it is wait for implementations, for independent implementations. And so after it's published, then it becomes an RFC draft. This needs to be done after at least 6 months discussion within the whole internet community, so it's done open. Also this standardization process is an open process. And second prerequisite is that at least two independent implementations have proved that the proposed mechanism, the proposed method works well. And then this draft standard can become an internet official standard. So this was a very short overview about a large field, about the internet, the basic of the internet and the World Wide Web. I'm convinced that you are familiar with all the details, so this lecture was to remind you on this, because in our lecture, in our internet weakness and target lecture, we discuss the different attack points inside the internet, the different weaknesses in the World Wide Web technology. And so, of course, you need to understand this technology before you are able to understand the weaknesses or the shortcomings. Thank you for